Dear students, so we continue further with the Lewis dot cross structures. The examples which we are discussing today are discussing organic molecules C2H6, C2H4 and C2H2. As you know, this is the molecule of ethane. This is ethene. इतना तो आप लोगों ने स्कूल में भी पढ़ा हुआ है. And this is a molecule of ethyne. We just need atomic number and only the atomic number. We don't need the mass number also. Here we won't make the dot cross structures, which is based on the electronic configuration, the valence electrons. That's all. Carbon atomic number we all know is 6, and hence the electronic configuration of carbon becomes 2,4 and hydrogen 1 है. लिखने की कोई ज़रूरत नहीं है. It's known. Now we've got 2 carbons in this structure, correct? And there are 6 hydrogen atoms. So 1, 2, 3, 1, 2, 3. Okay. Now there are 4 electrons for each carbon. This is one single bond formed where carbon shares electrons with another carbon. Here it makes covalent bond with hydrogen and the covalent bond with hydrogen. Same thing here, here, and even in these 2 cases. This is how molecule of ethane is formed. As you see, all the bonds are single bonds. Single bonds are called the sigma bonds. Sigma bonds. And hence, I can say number of sigma bonds in ethane are 7. 7 sigma bonds. The first bond between any 2 atoms, is the single sigma bond. So the first bond, single bond, sigma bond. The first bond, the single bond is the sigma bond, the strong bond. Sigma bond is a strong bond. So first bond, single bond, strong bond, sigma bond. First bond, single bond, strong bond, sigma bond. First bond, single bond, strong bond, sigma bond. Now enough of singing, bahut gana ga liya. Now we proceed further. Take molecule of ethene. So again 2 carbons and 4 hydrogens are there. So they are placed equidistant, making an angle of 120 degree. Ethene has carbon-carbon double bond. So this is how carbon has made the double covalent bond. This carbon makes single bond with H. Again another single bond with hydrogen. Same way here. 2 hydrogens, 2 single bonds each. So this is the structure of ethene. Now the first bond, single bond, strong bond, sigma bonds. The first between these 2 atoms are 2 bonds. Anyone you take it as first. First is sigma. So 1, 2, 3, 4, 5. So 5 sigma bonds. and the number of pi bonds are just 1. So this is one pi bond, the pi bond. Similarly, we move to the next structure, that is ethyne. Here and H over here. Now there is a triple bond, so 3 electrons of each carbon is making the triple covalent bond. Remaining one electron of each carbon is shared with hydrogen atom like this. So the structure has got, you can see, no, this is the bonded region of carbon. This carbon, you can see. Similarly, the bonded region of the other carbon, the bonded region of hydrogen, and this is the bonded region of hydrogen. So that is how it is. As you see, number of sigma bonds are 3. 1 here, 2 and 3, and the number of pi bonds are 2. The additional bond, weak bond, pi bond. Okay, I hope this is quite clear to all of you. And now we go to the category of next set of structures. I'm moving to the next set of structures, wherein we will take the molecule of, we'll be taking the molecule of BeCl2, that is beryllium chloride and carbon dioxide. Let us take the molecule of beryllium chloride and carbon dioxide. So we will take BeCl2 and carbon dioxide. Okay, again what we need, atomic number of beryllium 4, and hence the electronic configuration is 2,2. Next is chlorine, atomic number is 17, and the electronic configuration is 2A7. Same thing over here, carbon ending number 6, electronic configuration 2,4, correct? Oxygen atomic number 8, and the electronic configuration 2,6. Now I'm taking beryllium. The central atom is beryllium, and there are 2 chlorine. So 1 chlorine here, and the chlorine here. Beryllium contributes its 2 electrons. Chlorine has 7 in the valence shell, so 2, 3, 4, 5, 6, 7. Same way here, 1, 2, 3, 4, 5, 6 and 7. There's one bond formed, another bond formed. So this is the bonded region of beryllium. This is for chlorine and another chlorine. If you see carefully, chlorine has acquired the octet. It has acquired octet. If you see beryllium carefully, it has less than octet. Less than octet. And we learned, when the central atom has less than octet, then such molecules are called electrophiles. They are the examples of Lewis acids. They are also considered as examples of Do you remember? Incomplete octet. These are the examples of incomplete octet. So beryllium chloride is an example of incomplete octet. The electrophile, that is the Lewis acid. It is an electron pair acceptor. Let us see carbon dioxide. Carbon in the center, 2 oxygen at 2 corners. Obviously that will be the geometry because there are 2 corners. So we can divide 360 into 2 parts, 180, 180. Now carbon has 4 electrons in valence shell. We know oxygen is divalent. So 2 to 4 to 6. 2 to 4 into 6. Okay, so these are the 2 bonds formed, these are the 2 bonds formed. So the carbon dioxide structure will be like this. This is the structure of carbon dioxide. Right? This is the bonded region for carbon. This is for oxygen and this is for oxygen. Now octet of every element is complete. That is the structure of carbon dioxide. Hope this is clear to you. Just waiting for around 10 seconds. So you just look at it and just grasp it. Be attentive. Okay, so I just erase this now and we go to the next set of structures. That is NO and CO. NO. Okay. We need nitrogen. 7. That is 2,5 configuration. Oxygen 8. That is 2,6. And we need carbon. Atomic number 6. So 2,4. Let us make the structure. We have nitrogen here and oxygen. Oxygen contributes 2 electrons. Nitrogen contributes 2. The bond is formed. But nitrogen has 5 in the valence shell. So 1, 2, 3, 4, 5. Oxygen has 6 in the valence shell. So 1, 2, 3, 4, 5 and 6. This can have a resonating form. See how? N O. Oxygen can contribute both its electrons instead of one, both given by oxygen in this case. So 2 electrons over, and here 1 it shares with nitrogen. So oxygen 3 electrons done. Total are 6. So 4, 5, 6. Since this 1 electron is here, this is electron deficient region, we indicate it by a plus sign. This 1 here and 2 over here. Lone pair, whenever the element donates the lone pair, it acquires positive. It has contributed the lone pair. Now we see the side of nitrogen. Here it is not contributing any. Here it has contributed 1. 1 over here. 2, 3. 1, 2, 3, 4. 1 more. 5. Since it has excess electron, this is indicated by a negative charge. Wherever there are excess electron, negative charge. Wherever there is electron deficiency, positive charge. Now carbon monoxide. Quite interesting. Very interesting example. Carbon monoxide. Very, very interesting example. Let us see. The carbon has 4 in the valence shell, of which 2 of them take part in bonding with oxygen. But when we do this, carbon octet is not complete, it has only 6. Suppose I say all 4 will make the bond, then 4 bonds cannot be made. You know, carbon reaches till triple bond. Single bond, alkane, double bond between 2 carbons, alkene, triple bond between 2 carbons, alkyne. There cannot be 4 bonds between 2 carbons. Just think of the reason why we cannot have 4 bonds between 2 carbons. Just think. Then you will not get the answer. So I will give you the answer later on. Now, out of 6, 2 of oxygen are used, but carbon needs 2 more. So oxygen will contribute its 2 electrons in the center, which will be shared between carbon oxygen both, since lone pair is given from here, plus sign. 2 electrons are left, and since carbon is an acceptor and has a lone pair, the minus sign there. This is the structure of carbon monoxide. These examples are really brain teasers. You must practice them to get very good fluency, very good speed on the structures. You need to practice them. So keep practicing. Padhai karte raho. Bye bye. Take care. Love and blessings.